Well, thank you all for joining us today for Data Center Infrastructure Management Radar Report, identifying the best solutions for achieving dynamic IT infrastructure efficiency. I'm Ellie Gould, and I will be your moderator for today's event. Our featured speaker is Steve Brasen, Managing Research Director at Enterprise Management Associates. Steve brings over 20 years of in-the-trenches enterprise experience in IT management, operational support, and engineering. Today, Steve's expertise is focused on systems management, with a particular focus on endpoint management, configuration management, and green IT. Prior to Steve held technical positions at Bell Communications Research, Unix International, WorldCom, and Agilent Technologies. Go ahead and turn things over to Steve. I did want today's audience to know that Steve will be concluding his presentation by answering your questions, so do feel free to log that any time throughout the course of the presentation by using the Q&A functionality located in the right-hand column of your screen. If you're in full slide view, simply look for the floating toolbar. You'll see a question mark icon. Click on that, and you can log your questions that way. So today's event is being recorded, and you will be receiving a follow-up email from EMA tomorrow, which will include the playback as well as a PDF of Steve's slides. And now to go ahead and turn things over to our featured speaker, Steve Brasen.
Thank you much, Raleigh, and thank you all for joining us today as we reveal the results of EMA's Radar Report on data center infrastructure management. For those who aren't aware, EMA Radar Reports help enterprises identify optimal solutions in key management practices by comparing leading vendor platforms side by side. Product capabilities are empirically rated based on in-depth evaluations and interviews with actual customers, actual users. Value leaders are identified by comparing their scores in strength against platforms' cost effectiveness. And vendors that stand out as having achieved significant value in particular areas are recognized with special awards. Now, today I have the honor of presenting the key findings of the research we recently performed in the DCIM market space. And at the end of this presentation, we'll do with some details of how to access the full DCIM Radar Report or the free summary if you're interested in that. So a quick look at our agenda. We'll start with an overview of the center infrastructure management. There are still some confusion in the marketplace as to what encompasses the scope of DCIM and vendors can truly be considered as to be DCIM solutions. So we hope to clarify the boundaries of the practice. Now go over the extensive evaluation process EMA undertook in assessing the DCIM market. So you see how we collected our data. In order to provide a fair comparison, it was essential to establish the baseline characteristics that we believe should be incorporated in ideal DCIM solution, against which the evaluated products can be compared. Now, this is not just intended to provide insight into the evaluation process, although it does that, but hopefully will also indicate the types of key features and capabilities organizations should be looking for when adopting a DCIM solution. I'll actually share with you the ground rules we established for the evaluation, and that will lead us to the actual overview of the DCIM market, where we'll reveal the results of the research and identify the award winners. Anyone who's managed or worked in a data center understands what a challenging environment it can be to maintain. What can appear to be orderly to the casual visitor is a complex ecosystem of infrastructure hardware, cabling, network devices, and environmental controlling units. The reality is that changes are introduced so frequently and so quickly that it's often not practical to optimize new deployments. And it's involved in the installation of a new server. Traditional data center management practices have in the past involved little than walking through the facility looking for available rack space or co-locating the server with IT equipment utilized by the same business unit. Network and power cables were often simply plugged into the nearest outlet, and at best, the devices were tracked in a simple document like an Excel spreadsheet. This is how organizations very quickly lose control over their data centers, resulting in poor performance, excessive cost for power and cooling, wasted effort by administrative staff constantly having to firefight infrastructure failures. And now, to be fair, IT managers and administrators are typically not at fault for having disorganized data centers. They have to maintain the ongoing operation of environments while addressing new and rapidly changing requirements with limited budgets, limited staff, and other limited resources. In addition, they have to achieve regulatory compliance objectives and meet very stringent service level agreement commitments. And all this is compounded by new levels of complexities necessary to support, for example, virtualization deployments, cloud infrastructures, consolidation initiatives, and multi-tenant implementations. Core problem in these out-of-control data centers is that they lack the visibility into their environment. Or are collecting infrastructure details, the information is too complex for them to quickly and accurately analyze. Centers really are ecosystems. When a change is introduced into the environment, it has an effect on every other infrastructure component. For example, when a server is added to a rack, it draws more energy from the power distribution node and increases ambient temperatures that will directly affect the performance of every other server or IT component in the vicinity. Neighboring devices overheat or have inconsistent power. They could experience serious problems and flood the network with error messages or fail to provide services to other production systems. Now, this complex chain reaction makes it difficult to identify the root cause of problems because IT administrators are unaware of the detailed interactions of each of the data center elements. Data center infrastructure management encompasses all the monitoring and management processes necessary to enable a holistic view of the environment, dynamically recognizing the relationship of any single device to all the others. It's important to recognize this goes beyond just data collection. DCIM solution must be able to rapidly analyze complex data configurations and environment conditions to immediately indicate to support personnel any problems, potential problems, or opportunities for improvements. The idea arm data center managers with the key information they need to make informed decisions about the planning, optimization, and ongoing maintenance of their IT infrastructures. There has been a lot of communication in the marketplace, identification of a DCIM solution. Products claiming the distinction that only offer a small subset of what is necessary to be identified as a true DCIM platform. For example, if a solution just provides a database for inventorying data center components, it is not a DCIM solution. It is an inventory and asset management platform. Or if a solution only collects data on energy consumption, it isn't a DCIM solution. It is a power management platform. At their minimum, a DCIM solution must provide automation support in 3 areas: data collection, infrastructure modeling, and analytical reporting. Data processes consolidate environment information in a centralized data repository. Collected data includes a detailed device inventory and health status of every physical asset in the IT infrastructure, as well as continuously monitoring environmental conditions, such as energy consumption, temperature, humidity, and airflow. This data is used to develop a digital model of the infrastructure that is regularly updated to ensure it provides an accurate representation of existing conditions within the environment. Although strictly required, this model is ideally presented in a graphical format that visually represents all the data center elements in an easily digestible format. The environment models are essential to establishing and presenting visibility into the interrelationships of all supported IT assets. Many of these relationships, however, requires a level of analytics that interpret the status of the complex IT ecosystem to rapidly identify any potential problems or inefficiencies. These conditions can then be reported, displayed, or alarmed to provide the timely and critical intelligence necessary for data center managers to make informed decisions on environment improvements that will have more effective IT performance and greater cost efficiencies. These core capabilities cross the boundaries that often occur between support organizations. For instance, large enterprises have a facilities management team that supports the physical data center, which is completely separate from an IT operations team that supports the servers housed in the data center. And initiatives for, say, conservation or reducing energy consumption requires efforts from both support teams. But this often be challenging because each team has different objectives and view of the infrastructure in different ways. These solutions provide the visibility for both teams to clearly identify optimal configurations and minimize disruptions during a change. DCIM touches on so many infrastructure elements. Finding a solution that supports any individual organization's requirements can be a bit challenging. There are a number of vendors claiming to support DCIM today, and their marketing messages can, unfortunately, more to confuse business customers than to inform them. To help organizations at least narrow down the playing field in the identification of the DCIM solutions that provide the best value, we performed an in-depth evaluation of the market space. It finds value the comparison of a solution's product strength versus its cost effectiveness. It recognizes the fact that all organizations will have a unique set of business requirements, require a broad set of comprehensive capabilities to address more complex IT infrastructures, where others may have lesser requirements but more stringent budget constraints. The evaluation process ran over a period of 3 months and began with the development of a list of what we consider to be the core DCIM features and capabilities. This list was used to establish evaluation KPIs that were ranked and weighted based on discussions with IT operations and facilities managers, survey-based research that we had performed, and knowledge of our general knowledge of the enterprise requirements and best practices. For these KPIs, minimum level of functional requirements was established to identify which management platforms qualify for recognition as DCIM solutions. Minimum requirements included providing automation to perform all 3 principal process elements: data collection, infrastructure modeling, and analytical reporting, and also the ability to holistically deliver visibility across the entire data center infrastructure, including both physical assets and environmental conditions. The vendors that we identified were invited to participate in the evaluation process and were submitted a detailed questionnaire on the capabilities, costs, and supportability of their respective product sets. More than 150 points comparison were considered, and all responses were carefully vetted for accuracy. EMA also conducted interviews with vendor customers to confirm product capabilities and to indicate customer satisfaction with the product sets. Scoring of the vendor solutions was mathematically tabulated by correlating available features, architecture, price, and capabilities against the predetermined KPIs. I believe nothing replaces firsthand experience with the product set. Some feature scorings were adjusted to reflect input received from customer interviews. Final scores for each product set were used in the product comparison charts and in determination of the award winners. The we use for this evaluation is actually based on a series of standardized evaluations we call the Radar Reports. EMA produces detailed Radar Reports on a variety of IT management topics. So if you're interested in other topic areas, you may want to also check out the reports we've developed in other topics. They're available on our website. There's a little shameless plug there. Radar Report evaluations review support capabilities in 5 distinct categories: architecture and integration, functionality, deployment and administration, manage, and vendor strength. And a set of KPIs was developed for the DCI Radar Report in each of these 5 areas. To give an idea of how we rated vendor solutions in each of these categories, I'll share with you the characteristics that we believe should be included in a preferred solution. So start architecture and integration. Architecture speaks to core design of the platform. Solutions should be deployed on a single centralized management console, and all features should be accessed from a single unified interface. Ideally, the interface should be 100% web-based so that it is accessible from any device at any location. No one to be called into the office at 8 a.m. because a heat alarm went off, let's face it. So being able to remotely access alarm information is critical for most administrators. With a web-based interface, administrators can immediately access the solution from a laptop or even a tablet today without leaving the comfort of their own home. Obviously, a DCIM solution should also offer comprehensive data collection, and an ideal platform will automatically detect and record asset and status data from all data center components, including servers, environmental units like chillers, network devices, storage devices, environmental sensors, power distribution units, and intelligent racks. In addition, there's been recently been a significant increase in the adoption of embedded technologies such as IPMI, Dell VROC, HP ILO, Intel DCM, and several others. These are hardware components that are part of a data center system, operate independently, provide opportunities for detailed data mining about the servers and devices, even if systems are powered down. So direct integration with embedded technologies can be very valuable if you have any of these devices. To data collection opportunities, a broad range of protocols must be employed, such as SNMP, WMI, Modbus, and BACnet, and all collected information should be recorded in a single centralized data repository. Scale of a product set is credited when the solution easily enables expansion to meet increasing enterprise requirements. Now, we have a modular approach in achieving scalability as it allows organizations to adopt and expand the platform according to their size and level of DCIM maturity. To be effective, modules must be fully integrated. Topic of integrations, an ideal solution will be directly integrated across all the products components in the solution set. The integration implies that the solutions share common code, employ common data collection processes, utilize a common management interface, and or store data in a common data repository without the need for additional customization. Advantageous if direct integrations are established with third-party solutions. For example, federated access to a configuration management database, or integration with virtualization management platforms such as vCenter, or the ability to directly execute automated tasks on server management solutions like Microsoft System Center, IBM Tivoli, or C server automation, or the ability to directly access and update records on a service desk like BMC Remedy. For platforms where direct integration is not available, APIs should be provided to allow easy establishment of custom integrations. The core of any management solution is the breadth of functionality it offers. In DCIM, this speaks directly to the monitoring, analyzing, and reporting capabilities of the platform. Nearly every data center management practice can be enhanced through these automated processes. However, we identified several specific areas of support that all DCIM platforms should include to be considered comprehensive. For asset management, the solution should collect and record attribute and status detail for all physical devices in the data center. Examples of key device details to collect include its brand, model, configuration, host name, owner, purchase price, operating system, IP address, MAC address, firmware versions, health status, network performance status, and attached peripherals. It's a large list, and use your imagination, you can extend that quite a bit further. The solution should have the ability to group assets, for instance, by organization or by user role or by physical location or network segments. This would enable consolidated views and reports. Ideally, a percentage of ownership should be assigned to each asset so that accurate calculations can be performed for chargeback and metering. For example, if you have a server that is 20% utilized by one group and maybe 80% by another, you can divvy up energy and other operational costs and respectively charge them back to each group. Calculated asset data must be modeled to enable a holistic view of the complete physical, virtual, and environmental IT ecosystem. Should ideally be graphically imaged to enable easy identification of physical asset locations, configurations, and status. The more detailed the data center imaging, the more rapidly administrators can absorb infrastructure conditions and decisions on environmental optimization. Now, 3D visualizations, for example, provide more accurate representations of infrastructure details than 2D visualizations. Graphical views should be provided for multiple scales as well, from individual devices to racks to whole data centers to entire facilities, locations, or even geographical regions supporting multiple IT infrastructures. Detail on energy consumption and distribution of the entire powertrain should also be recorded. This includes data for individual devices, racks, PDUs, UPSs, on generators, and any provider substation feeds. All energy consumption should be historically tracked, metered by use, and alarmed to ensure power caps and other limitations are not exceeded. Automatic power controls should also be included that initiate the schedules, the graceful shutdown of servers and other devices during when they are not actually being used. Management collects data on heat conditions across the infrastructure from live readings taken directly by sensors, chillers, embedded server technologies, or other temperature recording devices. Some students can estimate temperature conditions on each device by reviewing general configuration and performance data, but this will yield less accurate results than if they are actually taken from real temperature recording devices. Should be visually modeled and mapped so that administrators can rapidly identify hotspots and reduce costs related to cooling. Air conditions will also affect heat distribution. An ideal solution will identify airflow requirements of devices and how existing airflow affects thermal conditions across the data center. Space management capabilities should include the identification of available data center floor space and rack space. Capacities as well as power and networking availability. Automation that quickly identifies available space based on administrator identified requirements will greatly simplify processes for device adds, moves, and changes. Going on the real-time modeling of data centers, hypothetical models should also be made accessible that can accurately predict the impacts of an alteration to the IT environment before actually implementing it. Sometimes these are referred to as what-if scenarios. For example, prior to the deployment of a new server, a hypothetical model could be created to see how that server will affect power and thermal conditions of devices that share the same rack or on neighboring racks. Leveraging this, administrators can optimize the new installation before actually deploying it, reducing error and remediation times. Hypothetical modeling also allows organizations to proactively identify optimal data center configurations without impacting their production environments. You just play with moving around equipment in the 3D model and see what provides best results. Hey, if you got kids and you could just have them do it. I know my 10-year-olds love playing with those kinds of 3D video games. The only place you don't want kids, though, is in the actual data center. In fact, the only folks that should be allowed in the data center are those that need to perform field repairs or updates. And those should be only in extreme cases. The traffic there is in the data center, the greater the chances of security breaches and unexpected failures, such as the infamous tripping over the plug incidents we've all heard about or experienced. As in control capabilities, enable secure remote console access to data center resources. Integrating remote access directly into a DCIM platform allows administrators to instantly react to alerts and conditions reported by solution and feed the results back to the system without engaging in what we sometimes call swivel management. Reporting is essential to identifying the status of the environment, identifying areas for improvement, achieving proof of compliance. Critical reports should be provided out of the box that identify critical IT conditions across the infrastructure. For example, power usage effectiveness, PUE, should be continuously calculated and reported to provide a key indicator on the level of computing energy efficiency in relation to total data center energy environmental costs. Should also be provided to immediately alert administrators when conditions such as power, temperature, or performance spikes exceed established thresholds. Organizations that engage in environmental certificate tradings or are subjected to regulatory compliance will also require periodic reporting of energy consumption and associated carbon generation. Deployment administration. Next to the 5 categories. Before, during, and after the radar evaluation, we had the opportunity to speak to a number of data center managers that had introduced a DCIM solution or attempted to introduce a DCIM solution, and there was one common theme that we kept hearing about. Initial data collection of infrastructure details is the single most challenging task in DCIM implementation. Organizations were not successful, noted that there were simply many data elements in their environment that needed to record manually because their management solution would not collect them. Successful organizations were able to overcome this difficulty with perhaps a little effort, but then the environment became exponentially easier to support after the introduction of the DIM. So they have to get over this hump of initial data collection challenge. The goal here is clear. Solutions that simplify data collection are much more apt to lead to a successful infrastructure management. Related features to this would include automated detecting devices, automating data collection, of course, direct integrations with data collecting elements such as intelligent sensors, racks, and PDUs, Other advanced features would include integrating with solutions with those that read barcodes and RFID chips, which can further reduce the amount of necessary manual data entry. Visually modeling the collected data can also be a time-consuming task if left to manual processes. So an ideal solution will natively provide and continuously update a massive library of device images that can be selected and dropped into the data center graphical representation. Out-of-box graphical elements should include servers, racks, environmental equipments, PUs, and networking devices, all of which should be pre-populated with details such as the device dimensions, weight, power consumption, thermal requirements, indicator lights, and cabling ports. It's not possible to provide pre-built representations of all possible data center devices. So a facility should natively be included to build custom device graphics. The resulting visual model of the data center should provide an accurate representation of real-world IT infrastructure that intuitively displays the status and conditions of the environment, allowing administrators to rapidly respond to conditions and events. Vendors must also display a commitment to supporting the DCIM platform and the user community. Maintenance contracts should be offered that deliver responsive and continuously available live support, as well as timely product updates. They offer professional services that are staffed with support professionals that are knowledgeable about their solution set, and DCIM processes to assist customers with training, problem solving, environment optimization, and the initial product deployment. Vendors should also engage the user community by hosting online forums and regular conferences or meetings to educate organizations on the effective use of their platforms and on DCIM best practices in general. Price models for a DCIM platform should be simple to understand and easy to calculate. Of the platforms we evaluated, nearly all offer fixed license pricing based on the number of supported endpoints. So, for example, the number of individual servers being supported, or the number of total devices, or the number of racks being supported. Similarly, consistent annual maintenance fees are typically calculated as a percentage of the total license cost. Vendors actually offer the first year of maintenance free, so that might be something to ask about. This is where you have to be careful, though. Organizations sometimes make the mistake of only considering license costs when evaluating a solution, and recommend considering both current and future enterprise requirements when choosing a platform to ensure that you get best value for your investment. Purchasing a low-cost solution may impede an organization from achieving long-term DCIM goals if it does not provide all the capabilities the organization will require. However, purchasing a more comprehensive solution may not be the most cost-effective answer if the advanced features are never used. The key is to clearly understand what your goals are and right-sizing the solutions to match. The vendor is an indication of its stability and commitment to its platform and solution set to provide assurances for long-term viability of the platform. Other that is financially strong with high revenue and vast equity is more likely to continue support for a management platform. Solution providers that invest heavily in research and development will also be assured of maintaining continual value in the platform architecture and feature set. Strategic and channel partnerships also increase the vendor's relevance in the marketplace. Additionally, a vendor's vision and strength for development, innovation, and foresight of future requirements indicates whether a management solution will continue to maintain its value. And naturally, customer loyalty and visible credibility help to ensure the platform will maintain popularity. For us to perform a fair and comprehensive comparison that is as fair as possible, we had to set some basic ground rules. First of all, we only considered capabilities that were generally available at the time of the evaluation. Features in beta test or those scheduled for future release were not eligible for inclusion. Features had to be completely self-contained within the package set. For vendors that included multiple products or modules in their DCIM suite, we ensured pricing was added for the entire products that we evaluated. So whatever we reviewed was priced in the pricing. So that we felt that provided a compare balancing of the two. And finally, we required all features to be clearly documented in public available sources so that we could verify it actually exists. For initial evaluation, we needed to have a level playing field for an apples-to-apples comparison. Since there are different pricing models, we had to develop, and what we did was we developed and priced out 3 sample infrastructure models for each solution. A small infrastructure model with 3,500 servers, a large infrastructure model with 70,000 servers, and a multi-site infrastructure model which included 5 small and 5 large data centers. Costs for the highest level of maintenance were applied to each model and annualized over a period of 10 years. Total costs for the solution licenses and 10 years of maintenance were then calculated for each of the 3 models and empirically rated on a pricing scale. Ratings for all 3 models were then averaged to provide the final scoring that we reported. While we believe that this provides a good general indication of the cost advantages of the solution, we recommend each organization request pricing quotes and perform its own financial evaluation to more accurately compare the products as they apply to their unique environments. Okay, now, the moment you've all been waiting for, the results from the evaluation. Earlier, we believe that value in any solution is defined by comparing the strength of the platform with its cost effectiveness. The EMA DCIM Radar chart here shows the 7 premier vendors we identified and evaluated. The vertical axis, product strength, combines evaluation scores for functionality and architecture and integration. Following of this axis, solutions that met or exceeded what we considered all the essential requirements for a comprehensive DCIM solution achieved a high rating, and only Emerson, iTraxx, and Nlyte clearly achieved this distinction, with Cormant just on the line. The horizontal axis, however, identifies cost efficiency by adding the scores achieved for cost advantage and deployment and administration. Our belief is that total cost of ownership in a solution includes the direct cost of the platform as well as the indirect cost associated with ongoing operation of the platform. Since deployment and administration speaks directly to the ease of use of the solution, we believe it weighs equally in determining cost efficiency. The size of each one of these bubble indicators indicates the vendor strength. By the way, I should also point out at this point that we also identified 3 additional vendors that offer DCIM solutions that we felt warranted inclusion in the report. They were CA, IBM, and Schneider Electric. However, due to various reasons, we were unable to perform a complete review of them, so they weren't included. I'm very hopeful at this point that we'll be able to include them in this version of the report when we revise the research in about 2 years. Those vendors, though, of the more than 100 other solutions we looked at, we were unable to identify any other products that could reasonably be considered to provide true DCIM capabilities. So every vendor on this chart warrants recognition, in our opinion. Let me give you a brief review of the vendors we evaluated. These are listed alphabetically by award, so don't read anything into the order. Starting Value Leader Award winners, Cormant has popularly been recognized for delivering comprehensive data center asset tracking functionality, and expanded its flagship solution with its now called Cormant CS. It was previously known as CableSolve. It was expanded to match all power and data connectivity in an infrastructure and visually model the environment. Although it is one of the most cost-effective solutions we evaluated, Cormant CS includes some very unique mobile device support capabilities that allow remote auditing of barcodes and RFID tags, as well as mobile console access to the management platform. This is Emerson Network Power, leveraging technologies that were initially developed for its Aperture and Liebert product lines. Emerson has recently introduced Trellis, which is a new management platform that was purpose-built from the ground up to provide fully integrated DCIM functionality. Direct integrations that extend into some of the vendor's other management solutions. Emerson's DCIM solution built the most comprehensive feature set we evaluated. Particular note is the platform's ability to deliver real-time infrastructure views, broad support for virtualization and implementation, and direct integrations with every single leading embedded technology platform we could find. FieldView was identified as one of the lowest cost solutions in the DCIM market, while still delivering key management capabilities for DCIM. With visualizations that incorporate multi-tenant views and thermographic imaging, we believe FieldView is well suited to support the essential infrastructure requirements of both large enterprises and service providers. Hands offers the most detailed and comprehensive visual modeling capabilities in the DCIM market. The IRX converged physical infrastructure management software portfolio, or CPIM, was built on an open systems architecture and delivers holistic visibility in an entire IT ecosystem. CPIM enables simplified integration with third-party management solutions and includes project management capabilities that can track deployment projects through every phase of its implementation. To the strong value award winners, with Modius, focused on helping organizations achieve operational efficiency. Most open data provides monitoring and performance analytics designed to improve data center infrastructure configurations and management processes. Open data consolidates and normalizes performance data for every device in the data center, including both heavy and light equipment, and provides status information on a variety of reports, dashboards, and alarms. Enlight was founded by data center professionals determined to evolve infrastructure management processes beyond just spreadsheets and Visio diagrams. Enlight software introduced a DCIM platform that was specifically designed to provide the predictive intelligence and management controls that nations need to reduce operational risks and achieve more efficient and highly available data centers. The Enlight DCIM suite is comprised of a fully integrated set of modules delivering capabilities for business process automation and intelligent capacity planning that enable the optimization of IT infrastructure, power, cooling, and space. And finally, Raritan is focused on developing solutions for power management, DCIM, and remote connectivity for data centers of all sizes. Raritan has established a global presence and is well recognized for enhancing data center management processes. The Raritan solutions we reviewed, the D-Track, DCIM software, and Power IQ energy management software, collectively provide real-time information about facilities, networks, and devices, and visualizes infrastructures, enable better data center effectiveness, and achieve greater energy efficiency. Of particular note are capabilities for budgeting energy consumption across all elements in the power chain, workflow and change management support, and comprehensive asset management as well. In addition to the value awards that we gave out, we have also identified several participants that we believe earned special recognition for achievements in specific areas. First went to Emerson Network Power, which we determined offers the most comprehensive DCIM solution across all key evaluation areas, including asset management, power management, thermal management, management, server management, access and control, visual management, and reporting and alarming. Of particular note, we found that where most other DCIM solutions focus primarily on supporting facilities management requirements, so environmental conditions, Emerson's solution also includes server access and support capabilities that are critical supporting operations requirements. Now, we believe that the inclusion of resources to directly enhance the security and support processes of servers, as well as those of environmental conditions, is critical to creating a holistic monitoring and support infrastructure that bridges the gaps between facilities management and IT operations. On this basis, EMA has determined that Emerson has provided the most comprehensive DCIM solution set for balancing both sides of the IT infrastructure management equation. I mentioned earlier, IRAX stood out to us as providing the best visual modeling. The level of visual detail in the iTrack CPIM 3D modeling platform, coupled with the solution's point-and-click navigation, simplifies the ability of organizations to rapidly identify conditions across the IT infrastructure. Space management, infrastructure densities, and asset utilization can all be optimized using CPIM's in-context view of the spatial relationships and interdependencies that are consistently changing in a physical infrastructure. IRAX delivers a fully interactive 3D model of entire enterprise infrastructures, from devices to racks to data centers to office buildings to industrial environments. That all enhanced by several advanced features, such as enclosure pads, which allow the location of cabinets, racks, mainframes, and other assets to be predetermined within the environment. visual imaging also provides detailed graphical representations of the complete network connectivity and power connectivity. This robust modeling capabilities delivered by TRAX we felt warrant special recognition for being a holistic management DCIM platform visually represents the complex web of interrelationships that exist in large physical ecosystems. And we also identified Enlight as providing the best scalability of a solution we reviewed. By protecting its DCIM suite as fully integrated modules, Enlight has enabled organizations to pick and choose which capabilities best fit their requirements and budgets. To simplify pricing models, Enlight has packaged these modules into logically segmented editions that allow the expansion of DCIM capabilities to directly correspond to the level of an organization's DCIM maturity. Our evaluation of the DCIM market space indicates that many solutions providers offer platforms that easily scale up in large enterprises. Very few offer solutions that also scale down to support mid-sized organizations. The Enlight DCIM suite goes in both directions. It does so without compromising on key capabilities. Entry-level Express Edition delivers all the core functionality organizations need to begin their journey into DCIM. As the enterprises move up along the DCIM maturity curve, they can easily transition to more advanced editions without impacting established management processes or having to retrain administrative staff. We believe this modular approach and eminent scalability architected into the Enlight DCIM suite deserves special recognition. And with that, I'll turn it back to Raleigh to tell you how you can access the free report summary or the full DCIM Radar Report. He'll lead us through the Q&A.
Thank you, Steve. You will be receiving an email from Enterprise Management Associates tomorrow, and I will provide direct links to both the full report as well as the free summary. If you are anxious to get your hands on those documents before then, just go to enterprisemanagement.com/research, and both of those reports are available now. Steve, I'm going to go ahead and jump right into the questions, starting with what is the difference between DCIM and converged infrastructure?
That's actually a great question. The technique has caused some confusion since they both deal with managing infrastructure. At core, converged infrastructure is about enabling the monitoring and management of all data center resources through a single interface. DCIM, on the other hand, goes beyond converged infrastructure to enable a holistic view of the IT ecosystem that dynamically understands the relationship of one device to all the others. In many ways, converged infrastructure can be considered a subset of DCIM because enabling a holistic view requires a unified monitoring. Other aspects of DCIM, which are modeling and analytical reporting, exceed the requirements and generally the capabilities of converged infrastructure solutions.
Thank you. The next question is, how does DCIM bridge the gap between IT operations and facilities management?
You covered this a little bit earlier, but to go into more detail, by providing a common view of the environment. As an example, think about achieving energy efficiency. IT operations is responsible for maintaining server performance, but facilities pays the electric bill. So who should be tasked with reducing energy costs? It has to be both of them. Facilities can determine which IT components need to be reconfigured, and operations can implement the change. To work together, they need to be looking at the same data that comprehensively addresses each of their specific job tasks.
Great. Thank you. There's a question regarding how do these tools complement or duplicate the functionality of the CMDB? Is there a duplication of data entry and updating of components, relationships, etc.?
That's a great question, and it goes beyond just DCIM. When we talk about IT management in general, we run across this question all the time. At the core, any IT management solution needs to do data collection. It needs to store that somewhere. Most IT management packages will have some sort of centralized data repository that it uses, but if you're implementing ITIL in your organization, if you have a CMDB, that is going to be a centralized data repository for all of your management solutions. And it will be you'll have faded relationships between the CMDB and the management solutions. Now, it's no different with DCIM. The DCIM solutions themselves will have a local repository that is centralized for its data collection. But ideally, it should be able to interact with the CMDB so it can share data back and forth. So you don't have to collect the data multiple times. You have one story of truth, as they say, for the entire IT ecosystem.
Steve, another question that came in is regarding who's driving the acquisition of these tools. Specifically, this audience member wants to know, are you finding that IT operation professionals are investing in DCIM solutions, or is it still facility folks who drive the acquisition of these type of solutions?
That's another great question. As you kind of note there, primarily what we are seeing is that it is the facilities managers who are purchasing the solution, and that's a surprise. I think, as I mentioned earlier, most of the solutions out there are geared towards environmental conditions and bringing those together in a holistic view rather than the server management piece. So facilities is generally driving this. I think what we are seeing is an interest in bringing that together. That is to say, by integrating the DCIM solution with traditional IT management platforms, we create an integrated single pane of glass console that both sides can use to be looking at the same data.
Great, thank you. And a review of all these products, Steve, this audience member wants to know what, if any, features are missing in all the solutions you looked at.
As these solutions are, there are still some room for improvement, as there are with any management platform. For instance, we found that very few solutions natively provide full computational fluid dynamics in determining airflow and its relationships to the thermal conditions. CFDs work with a data center model to graphically show the direction of airflow in the data center. We did note that several of the platforms do integrate with third-party solutions that provide this capability, but we expect as the solutions evolve, CFDs will more commonly included as a native to the solutions to identify and predict environment conditions. Also, with the exception of Emerson, the solutions that we saw provided very little management capabilities of the servers themselves. Although all of them provide APIs to integrate with third-party systems management platforms, it would be nice to see more direct integration for truly unified data center management. Actually, something that we are seeing in the messaging from the vendors is to move in that direction.
Thank you. Let's take one final question, and that is, how broadly have DCIM solutions been adopted from your research, Steve?
Actually, we're actually just kicking off some survey-based research that will directly answer that question with real numbers, because I'm curious about that answer myself. But I'll share with you from discussions and case studies we've performed. That adoption is in progress. What I mean by that is a large number of organizations have purchased management solutions, but few are currently using them to their full potential. Shouldn't be a surprise. DCIM is a fairly young practice, having only been fully defined a few years ago. Covers a broad range of topics. Organizations are more apt to adopt a solution to meet an immediate need, such as a data center migration or consolidation, or to reduce energy costs. And the organization will fully expand the solution into supporting other requirements. The value that can be achieved from adopting any of these solutions is easily quantifiable. So my expectation is that DCIM adoption will only continue to accelerate.
Information to have, and it sounds like something for our audience to look forward to as well. That concludes our event today. I wanted to thank everyone for taking time out of your schedule to attend. As I mentioned at the start of the presentation, you will be receiving a follow-up email from Enterprise Management Associates tomorrow, and it will include the playback of today's webinar, as well as the direct URLs for both the full DCIM Radar Report and the free summary. So be on the lookout for that. Thanks again for joining us, and enjoy the rest of your day.